Hey guys, Travis Gillespie, and in the last couple videos we've been looking at triangles. We're going to look at some more here. And let's take a look at an isosceles triangle and try to figure out what the internal measures are. In fact, the last video you actually looked at not an isosceles but an acute angle and learned through the triangle sum theorem, the triangle sum theorem, that there's an actual formula for solving for the angles inside of a triangle. Well, the thing that you know about an isosceles triangle, maybe you don't know, maybe we need to do a refresher here. An isosceles says, hey, two of the angles are the same size. So I'm going to call these G. So two of the same angles are the same size. So I've got an angle that's 88 degrees. I've got two that is worth G degrees. I don't know what their actual angles are other than that they are G. And if they're both labeled G, they're both equal. Well, that's easy to think and believe because you know it's an isosceles triangle. Isosceles triangles have two angles that are the same. So let's set up the formula with the triangle formula theorem. It says, hey, G degrees plus G degrees has got plus 88 degrees has got to equal 180 degrees because all of the inside angles added together, the sum of the inside angles equals 180 degrees. Well, the first thing that I want to do here is let's just simplify this a little bit more. I've got two G's here. I'm going to combine like terms. Say, hey, I've got two G's. So 2G, fix that G up a little bit, 2G degrees, and plus 88 equals 180 degrees. Well, the next step is let's actually isolate the variable as much as possible and subtract 88 from both sides. So when I subtract 88 from 180, I get 92. Well, that equals, I'm going to undo this and just write it over, keep it clean. So now I have two, let's go back to green as well. So I've got 2G equals 92 degrees. Cool. So the last part here, G is not isolated. It's still being multiplied by 2. The way to undo multiplication is through division. So divide both sides by 2. And I should be able to get, let's change those colors before I just finalize everything. But 92 divided by 2 should be 46. So G, in fact, should actually equal 46 degrees. Cool stuff. So G degree equals 46 degrees. And to finalize, to check everything out, once you've finished, to check it all out, you just say, hey, check by saying, well, 46 plus 46 plus 88, well, 46 double is 92 plus 88 should equal 180 degrees. Cool, it does, it checks out. Great. Let's move on to a second problem here. Cool, let's take a look at another one here. Let's draw up the triangle here. Let's call this an equilateral triangle. And the cool thing here, it's an easy one to do. And I'm just going to call all of these G. I'm going to say these are all G degrees. Why are they all G degrees? Because they're equilateral. All measures, all angle measures on the inside are equal. I'm going to just clean up that last G. Cool. So all you really have to do with the triangle sum theorem here is say G plus G plus G equals 180. But I could have been a little bit faster. And instead of writing all three G's out, just combine like terms at the beginning and just say, hey, 3G equals 180. Cool. So now moving from here, the next thing you want to do is isolate that variable. So divide both sides by 3 that's going to give you G equals 60. So G degrees equals 60 degrees. Cool stuff. Just a couple of clarifying thoughts here. Equilateral, not only with equilateral triangles, but with triangles in general, you're going to see these types of triangles all the time. Whether it is an isosceles triangle, an acute triangle, or isosceles up top, or an equilateral. You're going to see them all the time. So it's good to remember not only the triangles themselves, the types of triangles and what their measures equal, but the triangle form triangle sum theorem, because it's going to help you. That formula will help you in tests and future classes. And let's move on to another problem here. So the last one that we're going to look at up here on the board, let's throw up, we'll call it a scaling triangle. And the thing that you may or may not know about a scaling triangle is that none of the sides nor angle measures are congruent. Another way of saying that is, hey, so that's a real ugly triangle. I'll go ahead and fix that. Is that it's just saying, hey, none of the angles or measures are the same size. And you know, the cool thing about triangles is, although these that may not look perfect as you would find them in a book, they are coming from my hand. And in fact, if you're watching this, I'm hoping that you're drawing it with your own hand, because it helps you to realize that as long as you understand what's going on in the problem, the triangle does not need to be drawn to scale. So what I'm given here is a scaling triangle. The first thing you'll notice, there's really no numerical value of saying, hey, this is worth 25 degrees. And it doesn't say that at all. It says this is worth 3s degrees, 4s degrees, 5s degrees. So what I'm given here instead of numerical values are variables. And the other thing that I know about this is that the sum of these angles, using the triangle sum theorem, says, hey, if I add all of these angles together, I get 180 degrees. That's the first thing I'm going to set up as my equation here. Let's do it up top here. 3s degrees plus 4s degrees plus 5s degrees has got to equal 180 degrees. Let's go ahead and combine all like terms. Well, 3 plus 4 plus 5 is 12s. So I've got 12s equals 180 degrees. Now the next step I want to do here is to isolate the variable. The only way to do that is to get rid of the multiplication going on. So divide both sides of the equation by 12. When I do that, I get s equals 15 degrees. But be careful, because you're not done yet. In fact, you've got to substitute 15 back into each angle measure. So let's start with 3s. 3s degrees. Well, that equals 3 times 15. And 3 times 15 is 45 degrees, so s equals 45 degrees. 3s equals 45 degrees. That came out sloppy, so just going to go back and I think I'm going to leave it like it is. This is 3s equals 45 degrees. Cool. And I'm just going to box this up and draw an arrow to here. Now let's move on to the next one. So the next one here, I'm going to do in blue. I'll say, hey, all right, so let's look at 4s. Well, 4s equals, it's 4s degrees. 4s equals 4 times 15 plus degree equals 60 degrees. There, right there. Finally, we got 5s degree equals 5 times 15. 5s equals 15 times 5 is 75 degrees. Toss this guy up. So now I've got the measure of my three angles. Cool stuff. And I'm passing the 11-minute mark, so I'm going to wrap it up here. But if I were to add 45 plus 60 plus 75, you get 180 degrees. Cool stuff. Have a great one.